Hi, I am 3 honor students. Welcome back. We are going to continue where we left off on 7.6 properties of radicals, example number 3. So for this first example, part A, we are going to have the cube root of 1 over 27, excuse me, that's negative 1 over 27, and then plus the square root of 4/9. So we are asked to add those two. So we need to simplify the one on the left and the one on the right. The one on the right is probably easier for most of you. So you know you're allowed to break up the top and the bottom, or the numerator and denominator. So the square root of 4 is 2, and the square root of 9 is 3. Over here, the cube root of negative 1 is going to be negative 1. And the cube root of 27 is 3, because 3 times 3 times 3 is 27. So I have negative 1/3 plus 2/3 is just going to be 1/3. So that is A. So just because it has fractions in it, don't let it worry you too much. Okay? Just take it piece by piece. For B, we are going to do the 7th root of negative 128 minus the square root of negative 9 squared. Okay? So we need to know what to the 7th makes 128 if possible, or if there is something in there. And you might know that, and it helps to know, that 2 to the 7th is 128. So here, my index is odd, so the square root of negative 128 is going to be negative 2 minus, and here my index is 2, my exponent is 2, even, and my result is going to have an odd exponent, so this is going to be the absolute value of negative 9, and so that is going to be negative 2 minus 9, which is negative 11. So there was another example of even, odd, because our exponent right there was a 1, so even, odd. All right, let's go on to example 4. In example 4, we are going to simplify. That's one of our favorite things to do in math, is simplify things. And so we are going to have the cube root of negative 27 squared. So I have a choice. I can square 27 and then cube root, or excuse me, square negative 27 and then cube root. But that'll give me a really big number, and I don't want to have to use my calculator. So instead, what I can do is I can take the cube root of negative 27 and then square that answer if I don't want a really big number. So the cube root of negative 27 is negative 3. And if that is squared, I get an answer of 9. Sorry about that. Let's do B. B has the 5th root of 32 cubed. So again, off the top of my head, I do not know what 32 cubed is. So I am going to do this by taking the 5th root of 32 and then cubing that. So the 5th root of 32 is 2. I don't have to worry about absolute values because that's odd, right? Cubed is 8. All right, we're getting through this. Example 5. And we have to do lots of examples because so many different properties and so many different things can happen with radicals that there's just lots of things to show you. All right, Here I have the 8th root of 36. Now, if I go to simplify that, 2 to the 8th is already bigger than the number in there. So I really can't break this into a perfect power of 8. So I have to do something else. So what I can do, remember, is I can break up the index here into its factors. So what could I break 8 up into? I could break it into 4 times 2. So that's what I'm going to do here. I am going to break this up so that I have the 4th root of the square root of 36, because these two indexes here will multiply to give me my 8, because there's a little 2 there, even though it's not written. And everybody in the class knows the square root of 36 is 6. So my answer is just 4 root 6. No, 4th root of 6, not 4 root 6. I apologize. Too many radicals going on. The answer is the 4th root of 6. All right, let's go on to example 6. You're probably wondering, how many examples are we going to have today? Well, a lot. How about that? A lot. I'm on page 2 of my notes. So we're going to simplify. Surprise, surprise, simplify again. I think all of the examples are simplifying. All right, this time we're going to combine numbers and variables and big indexes and see what we can do, kind of putting a lot of properties together. So we have the 7th root of 128, x to the 8th. All right, so the first thing you ask yourself is, what is the 7th root of 128? Is it a nice number? Is there a perfect power of 7 that I can find inside of there? So let me just check. 2, oops, clear this out. 2 to the 7th is 128. Really good to know your powers of 2, especially in today's lesson. So I know the square root of 120. I know the 7th root of 128 is 2. My brain is turning to jello today. All right, and then remember this, how many times does 7 go into 8? It goes in 1, so I have 1x on the outside and 1 left over on the inside. So your answer is 2x, 7th root of x. And that looks more complicated than that, but it is simplified. All right, number 7, or example number 7. We're getting there, I promise. Simplify. All right, so here we are going to have the cube root of 24, x to the 7th, y to the 9th, z to the 10th. And we are going to simplify this. Okay. Is 24 a perfect cube? Let's try that. 2 cubed is 8. 3 cubed is 27. Neither of those are 24, but 8 goes into 24. So I'm going to change 24 to be 8 times 3. So here I know that the cube root of 8 is 2. And I'm still going to have a 3 inside my radical. Now I'm going to go on to my x's. 3 goes into 7 twice. So I'm going to have x squared on the outside. With 1 x left over, I'm going to put it on the inside. All right, 3 goes into 9 3 times with nothing left over, so I have no y's left over. 3 goes into 10 3 times, so I have z cubed, and I have a z left over on the inside. Now, even, even, odd, this is odd, so I don't have to worry about even, odd in this problem. example 8. All right, we are going to have the fourth root of 32x to the ninth over the fourth root of 2x to the fifth. So what we talked about in our properties is when you have a division of two radicals and they have the same index, you can combine them into a single radical with that same index. And why you might want to do that is to clean things up, is to simplify the fraction. Because 2 goes into 32, so that simplifies rather nicely. So this is going to be the fourth root. 2 goes into 32 16 times. And then I have x to the ninth on top, x to the fifth on the bottom. Subtracting those, I have x to the fourth. So that's what it's simplified to so far. The fourth root of 16 is 2. And the fourth root of x to the fourth is going to be the absolute value of x, because this is even, and my exponent is odd. And lots of people forget the absolute value there. Math teachers often do. So if you forget it, don't stress. It won't be the end of the world. Just try and check it when you can remember. All right. Last example. You never thought it was coming, huh? It's finally here. Example number 9. All right. We are going to have the square root of 200 x to the third, y to the sixth, z to the seventh. All right, is there a perfect square inside of 200? It's 100 times 2. The square root of 100 is 10. I'm still going to have a 2 left over in my square root. Okay, remember your index out here is 2. 2 goes into 3 one time with an x left over. 2 goes into 6 3 times with nothing left over, so I have a y cubed. 2 goes into 7 3 times, so I have a z cubed, but I have one z left over. So these things that are left over here in the bottom go in the square root. 2xz. I just noticed something in example number 7. I apologize. When I wrote this root over here, I forgot my index of 3. It's a really common mistake. I'm not going to go back and redo the video. I apologize for that. Go back to number 7, and that should have been a cube root. And if you caught my mistake, good job. Really easy to make mistakes with all these numbers all over the place. All right, so here this is a square root because my index was 2. So the only thing I haven't checked is even, odd. So let's check even, odd. This is even, this is odd. This is even, odd. So my y needs an absolute value. Okay, even, odd, so my z doesn't. So there you go. And we are done with the lesson. Good luck. It takes a lot of practice. We are at the end of the quarter, in chapter 7. It's our last chapter, so things are getting, a little more difficult here in honors, but take your time, ask questions, and you can get through it. Okay, guys, see you next time.